this Discord, so hopefully all goes well, and you'll see me over on the other Discord in just a moment. All right, I'm back. I think. Am I back? Can you hear me? Got me? Are we here? Is that a yes? Okay. Let's pop this window out. New YouTube stream. Now imagine doing this with Dr. Jackson live on stage at MPAC. I've had that happen and had to like remain calm through the whole thing. Like, okay, all I gotta do is reboot everything. Nothing to worry about. So, all right. Make sure I'm in the right stream. All right, we're back. We are on YouTube. We are on... Yes. Okay. So we were here, right? We've accumulated error. We've shocked Pikachu. Dun, dun, dun. All right, I love that slide. So I think this is where we wound up. Fixed update. Yeah. Oh. So fixed update. Unity has multiple update functions you've seen. You've kind of got a hint of that. Somebody's mic, Ryan, your mic is live, and you've got. Are you moving furniture? What's going on? There's something going on here. All right. Unity has multiple update functions which fall into two categories. We have the main loop, the main update loop sort of thing, no problem, and the physics loop. Think of them as that way. Now, they may or may not be, depending on when, how Unity is what iteration you're in and so on. But technically, they aren't technically running simultaneously. They are actually interleaved and interleaved unevenly. Right? Because it's really hard to really be simultaneous, right? Because certain things depend on other things. But with computers, we're getting closer and closer to that, depending on how you take advantage of multi-threading and so on. So this slide, I think I'm going to have to update this soon. I have to reanalyze the way the loops are running inside of Unity now. But ultimately, update runs inside the main loop and is run once per frame, however often that may be. And fixed update runs in the physics loop. No, we're not going to do compute shaders. Nope. Sorry. This is just intro after all. If you want to watch graphics for games programming, then we'll start talking about shaders, and we do all sorts of stuff in there. But that's a ways off. So the idea behind fixed update is to run as regularly as possible regarding... We don't do compute shaders, though. I wish we did. Maybe we should have more time. Regardless of frame rate, right? This is what, if you want to get another visualization here, is as time passes, fixed update sets out to, of course, go nice and evenly, whereas update we cannot really predict because it's going to depend how long it takes, what complex things we're doing in our update loop. We may have these uneven, like here, this one looks like it takes 2.5 or 3 compared to the others. Here's 2, here's, and so on, right? So that's the passage of time. So now we can get a feeling for what's going on in these two loops, and we'll fill in a couple more areas about, what happens where. So we had our main loop where our mouse event would occur, our input. We have update, then we'd have animation. After animations and updates happen, we have our late update. And ultimately, after late update, we render, right? Stuff is going to get drawn on the screen. Quote unquote, simultaneously with that, we have our physics loop running. And our physics loop is comprised of our fixed update stuff, the actual physics simulation phase, where Unity then goes in, looks at all of the forces, all the added forces, all the current velocities, all of the materials, and so on and so on and so on, and updates its physics model. And as a result, then we can say, after it does all that calculation it comes up with, and will resolve all of its collisions and things, right? So it can say, okay, I moved these things around, I looked at all the colliders and so on, and I'm going to call all of your collisions. And then it will say, okay, well, we're going to also resolve all of our quote unquote phantoms, the things that rely on physics to get executed, but don't necessarily change physical, the physics model, right? So our triggers. So if you do have a collision and a trigger on the same object and they use the same collider and whatnot, or something close to it, you can almost predict that, yeah, your collisions will happen first and then your triggers will happen. But if you're relying on, really careful synchronization, things like that, well, you might be tempting fate. I'd be careful. So, but that's the main thing to know. It's okay. This is the order that things are going to happen in the physics loop, and these are the things that are happening in the main loop. And you might think we're all the way down the rabbit hole now, but we're not. Even though we know why we have these tiny fixed updates and why these things are happening, because we have, running all our great math that we here, running it fast enough so that it looks smooth, kind of feels real, and so on. We're not quite there yet. All right. So one thing to have in mind, whoops, forgot about this slide. There are ways to change that fixed step. If you run your game physics once per second, you could do that. You could change the fixed time step to be 1. I've never actually tried that low, right? So there is a setting, right? If you go in here, actually, this is an older screen grab. I got to grab a new one. Project settings is now a dialog, its own little window that pops up, and you'll find a time tab in there, just like you have the physics 2D tab and so on. You can set the timestamp there, time step. You can also set the time scale, which is interesting because that's one way you can pause the physics engine or tell the physics engine to run faster or slower by changing the time scale. And there's a way to get to that using scripts as well. So the bottom line is, or why this is, we've talked about this. We've mentioned, okay, rigid body 2Ds in physics should be modified, should only really be modified during fixed update. In general, code that manipulates a rigid body 2D should be contained within fixed update. Can you get away with that? With doing things like adding forces inside of your update loop? Yes, you can. But you may run into problems. What do I mean by that? Say you called and you said add force, right? You added a force to a rigid body in your update. And your update is running at 120 hertz, 120 frames per second, which isn't that crazy these days. It will potentially add that force or run as if it's going to try to do the add force 3 times before the physics loop even has a chance to run. Okay. So it's at least wasteful because some of those aren't going to take effect, or you're going to wind up adding it 3 times and it's going to have this sudden pop in order to try to get to where it was going. So it's better to do anything with physics, even the adding of forces, if you're adding them over the course of time. If you're not doing just like one shot kind of stuff, you do one shot kind of things, those are the ones you can kind of get away with, right? But in general, you want physics stuff to be happening in fixed updates. So you want to separate out or decouple input and other things from the input detection and the physics movement, right? For example, you might need to do something like, instead of immediately applying a force or changing the velocity when you detect input, we did this, right? We have our input vector for our joystick, and then later on in fixed update, that's where we decide to actually add forces or torques or whatever, right? So that's why we do that. That's good practice. Now, like I said, may feel like we've gone all the way down the rabbit hole. We know everything there is to know about the Unity engine, but those who are really clever, who've been thinking ahead of time, we're not there yet. They may realize this. Now, in this sort of exercise here, the AM class didn't quite get it. So you guys, you folks, let's see if you can spot the error in here. I have confidence. I think you're going to be the ones to spot this. All right. So what we want to do is we want to lerp. Right? What lerping is, basically, it's kind of a nice, fun way to say interpolation. Right? Lerping is interpolating. Why is it called lerping? Because interpolation has a whole bunch of letters in it, and we want to have short terms for these kind of things. We have built-in functions that are going to help us interpolate. So what interpolation is, it's basically a mixing of things. And we'll have a whole lecture to talk about that, the finer details about, kind of clever things you can do with interpolation. But for now, just think if I have A and B and I want to mix between the two, I interpolate between the two, right? If I have a position 0 and a position where X is 10, so we have 0 and 10, if I said, okay, what's halfway between those two? If I averaged 0 and 10 together and took the average, I'd wind up with 5, which is in between 0 and 10, right in between them. I have interpolated the position in between. I have come up with something that said, okay, 50% or halfway in between these two things, the halfway mix of these two things is the position in between them. And that's fundamentally in that 3 sentences, that's that whole lecture on interpolation, right? We're mixing things. And what interpolating, lerping is going to do is we're going to have some t value, which is going to go from 0 to 1, which controls the ratio of the mix, right? At 0, it's all the way one way. At 1, it's all the way the other way, right? You can be 99% of the way there or 1% of the way there, and that will tell you, okay, how much of each of those things do you add together in order to come up with it's a weighted average sort of thing, right? With you have coefficients that say, okay, how close should I be to one edge of the two values or the other, right? It's start value or end value. At 1, I'm at end value. At 0, I'm at start value. At 0.5, I'm halfway between the two, and so on and so on. So that's interpolation in a nutshell. Imagine for this spot the problem that we have a time of 2 seconds. We want 2 seconds to pass, and we want to move from the starting value to the ending value over the course of 2 seconds. So I'm going to move across the screen, say from -5 to +5, and I want it to get there over the course of 2 seconds. I'd like to do it smoothly, right? I'm going to do it linearly, though. I'm not going to use acceleration and so on. I'm just going to linearly interpolate here, right? I'm not using physics, just because that would get even more complicated. So for now, we're just going to do it the brute force way. So over the course of this 2 seconds, I need to move from point A to point B, or start value to the end value. So the first thing I want to do is, since I do have a real-time system here where time is running, I can refer to the time, right? The system time. I can use time.time. It will tell me, okay, how many seconds have passed? So if I grab that number just as a reference, I grab it and say, okay, I'm about to start doing my interpolation. I'm about to start moving. So let's figure out my start time. Because I know at start time, I know I'm at start value, right? The moment the starter's pistol goes off, I know where I am, and I know, okay, start our elapsed timer running, right? So to figure out my 2 seconds, I have 2 seconds that I want to have elapsed. So I'm just going to use my timer to say, okay, here's when I started. Now, to check the elapsed time, I can always then compare, right? I'm going to say, okay, what time is it now? Subtracting the start time to give me the amount of time that has passed. It's very, very similar to saying, okay, what is the change in position, right? The distance between two positions is basically subtracting one position from the other. That gives us the distance between the two. Here I'm figuring out, okay, the time. Oh, wait, you already looked ahead. Somebody cheated. They went to the notes. All right, well, here's the problem. Okay, someone spotted the problem before it was even on the screen. So, okay, for everybody else who's not Dylan, so I want this while loop to get me I want it to last for that 2 seconds, right? Because I know that's how long I want it to take, right? So what I'm going to do on every time step or each iteration through this loop, I'm going to look at moving, changing this ratio every time through, right? So time changes, start time doesn't. So more and more time will have passed, increasing this number, getting it closer and closer to 2. And since I'm dividing by 2, it's going to go basically from 0 all the way to 1, right? If this maximum value here, this maximum elapsed time before I can leave the loop is 2, that means I'm going to go from 0 to 1, right? Because I'm dividing by 2. And then I would use my interpolation here. The idea was to use my interpolation to say, all right, math floating point dot lerp from the starting value to the ending value varying from 0 to 1, right? 0, 0.1, 0.2, 0.3, 0.4, and so on. And as Dylan pointed out, the problem with this, trying to do this, is if this was in update, this would be really bad. This would take 2 seconds for the update. And we already said we wanted updates to be as quick as possible. We want them to happen at frame rate, at 60 times a second, or 120 times, many times per second. If we tried to actually execute this inside of update, this would just, best case, it would stall for 2 seconds. Worst case, if time isn't actually even running, which it may not be, I have to check that, or I always get scared. I don't want to check that. I just don't want to do this. And this is where the computer crashed this morning, because the computer got so scared just of talking about this, right? Because there's nothing getting out of this loop, right? This is basically a 2-second dead loop. Nothing is going to be updated, right? Position isn't going to have a chance to change. It's not going to have a chance to do any updating, drawing, or anything, right? So even though conceptually this is sort of the right thing, I have time passing, these tiny little increments, the increment of each iteration of this loop, it's no good, right? It's just dead. So thankfully, we have something called coroutines. Now, coroutines is definitely the big brother, the fancy sibling, the top hat and tails compared to invoke, right? Invoke, we were able to say, okay, go run this routine 2 seconds from now, or repeat it every 2 seconds, or some rate. Coroutines, way fancier, way fancier. Coroutines are special functions that are executed. You could think of them as being incrementally executed, or executed in intervals, not excrement. That's terrible. Executed in intervals incrementally. Wow. That's you ever have your brain autocorrect? That's exactly what happened, right? And it was just a bad autocorrect in there. Executed in intervals incrementally. So my brain excremented that. So if you ever wondered why, those of you who have used coroutines a lot, if you've ever wondered why they're called enumerators, that's because that's a Microsoft thing, right? It's a C# thing where it's saying, okay, these were created to work incrementally over some amount of some bit of data or some course of time and so on, right? So these are incremental enumerators, or interfaces that, anyway, that's behind the scenes. It's trivia question about why they're enumerators. All you have to know is that they are enumerators. They're basically functions that can prematurely exit, which we've been able to do. You may have seen premature exiting of a function before just by saying, well, return. If you say return, like if condition return, that means you've executed the function without, but you never come back. The cool thing is with coroutines, you come back, right? So even after you say return, if you've said return the right way, it will resume where you've left off automatically. This is super useful for kicking off a process that needs to run over several frames, or some time, or over the course of any number of different things, right? It also lets them sort of run on their own. It gives you the appearance almost that they're running in their own thread, almost. But they're running all within the same thread, but kind of gracefully allowing other things to happen during the course of things, right? They're great for other routines that also maybe you want to wait for another operation to complete. So you can even tell it to say, okay, wait, I'm going to stop right now. It's okay if I pause until this other thing is done, right? So there's other things like that as well. You can say really fancy things. So let's do our bad loop now as a coroutine. Much easier, much better, right? First off, we have to tell it it's an enumerator. And we now have our function. It's not being called in update anymore. In fact, it's invoked via this start coroutine. So it might have gotten called from an update or triggered, kicked off, whatever, but it's not happening inside the update anymore. So the fancy piece of it is just this one simple part, yield return null. So what yield return null means is that you want to basically yield until the next frame update. Yield return null. So now this inside loop here is going to run at roughly your frame rate, right? Your updated frame rate. And it will let everything else. So like basically it hits that yield return null. It says, okay, everybody else go run your update. And next time around, come back to me. It's like putting in a bonus update function. But it's not just a bonus update function because you can mix and match. You don't only have our yield return null, which makes it like an update function. You also have things like yield break, which would stop the coroutine altogether. And my personal favorite, yield return new wait for seconds, where you can tell it, okay, come back to me, return to me after a certain amount of time has passed. So it look for basically an accumulation of time and say, all right, maybe you want to come back after 2 seconds or after a 50th of a second or after a 10th of a second, right? So you can say, I only need this bit of code to run this often, right? You can ask for it to wait for the end of this frame, which is different from update in that it's going to come back before the next update. At the end of this frame, but before the next update. Or you can even have it return at the end of fixed update. Or sorry, at the next fixed physics step after all physics is calculated. So last but not least, I forget this last one because it's the more unusual one for me, at least. You can also tell it, okay, wait for another coroutine to finish. So you can start a new coroutine and say, all right, I'm going to just wait here until this other guy finishes. Right? Sort of like almost like a traditional order of execution might work. So this now, and for those of you who are clever, you may notice how professionally put together this slide looks compared to the other ones. So this is the bottom of the rabbit hole we're going to go through today. And I think this gives you, pretty good indication of, how you can get your code to execute where in terms of Unity, how coroutines work and what you can use them for. All right. So inside of one frame, we have the physics portion and the normal update portion. So we have on mouse, then update our coroutines. If we are saying yield null or wait for seconds, they'll get executed up here before the animation, late update, rendering, and so on. Right. So after all the normal updates have occurred, but before these pieces, or we can say wait for the end of frame down here, which is even further down after late update. Or we can say, all right, I want to run this after physics, collisions, phantoms, after they've all been processed, have my code return there. Right? So if I knew I had something that I wanted to wait after physics has been executed, I can use wait for fixed update in there. Cool, right? So that's the end of the notes, the lecture notes. Let's look at a couple of kind of examples. Now, of course, everything crashed. So once again, I'm going to have to relaunch Unity. And Unity will take 5 minutes to come up. And I've been, continuing to do crazy things, what I think are crazy fun things. Mostly with the asteroids program now. So I'm over in the asteroids piece of things. Coming up with what I think is kind of a cool weapons system. So using inheritance, a little even more so than the first version I demonstrated. But I'll also show I want to show some coroutines and some of the things you might do with them. Now, you're always presented with options, or you're always, you have options in terms of how you do stuff. Someone in the other class did ask, oh, the thing you're about to do, couldn't you also do that as an animation? I'm going to show you how to do some like fades and things to and the answer is yes. I mean, you can almost always figure out some other alternative way to do something. And, that's a possibility. But for this, we're going to use, let's see, Unity still, I should put this on the screen here. 1 minute, later. So we'll do it with coroutines today. So it's up to you. I'd like to see you do somewhere between projects 3 and 4, incorporate the use of coroutines. So think about a good use. I'll show you my go-to use. I like to use it for fading in and out. Right. Certainly, you can do it with animations. You can animate the alpha channel of a sprite, for example. But come on, Unity. This is exactly what I did before. So I'm not going to be nervous. I'm just going to be impatient. Okay. All right. So here is not the scene we want to look at. And I'll go to the other scene that we do want to look at. Oh, it looks like another Unity instance is running. Uh-oh. That's slightly bizarre. All right, close that. All right, I think I'm back. Okay, good. I think I'm back. So first things first, we'll talk about coroutines, and then we'll get into my silly weapon system, and you'll see it sort of demonstrated. So people will ask about it, and hopefully we'll have some time. We'll get to show how the silly weapon system works. But for starters, let's talk coroutines. And we will go to asteroids. Now, to make this compelling, okay, I'm going to go ahead and play the game. I'm going to say maximize on play, and we'll show you some stuff. So you've already seen a coroutine. It happened. The coroutine's happened. Ready? I'm going to crash into something so you can see the coroutine happen again. Ready? Somewhere my ship's going to come back. Okay, the ship was up there. I don't know if you noticed it. I'm going to do it once again. I'm going to come over here, smash into something. Whoops. There we go. And somewhere the ship is going to come back. Where is it? Okay. Now, if you've noticed, every time it came back a different color. It kind of faded in a different color. And you also noticed our game over just faded out. Now just disappeared. And okay, blue screen, blue ship came back again. Oh, couldn't fire. Terrible things are going on. Everything's out of control. I didn't pay attention to the game. All right, now I can shoot. Mayhem, craziness. Game over again. All right. So I've turned over control of certain stuff to a coroutine, which is kicked off whenever the player ship dies, or even when the player ship needs to come into existence after either being dead or between the game starting over again. And it does that fade in, right? So it does a 1 second fade as it comes in. Now, if you notice, I think the asteroids at the beginning of the game, they also fade in. And let's see, what else? I think the enemy, let's see, the enemy is really brutal there. The enemy actually fades in as well. So let's go to the player, and we'll go to the player's the player ship controller. And actually, we'll look at the simplified version since we already have the simplified version from the morning class. We'll start looking there. So the asteroids that faded in and so on, I have a function called generic, or a class called generic fade. And all this class does is in its start, it starts a coroutine called fade in. And what it does is it said, oh, okay, I was looking at Dylan's comments from before. I was worried that we had some new comments. Okay, so the coroutine here, what it does is it grabs, or it sets the color of the sprite renderer for whatever object we're on, and it sets it to 1110, right? So when you have a sprite that has an image, you can tint that image, right? You can use this color value to tint the image. And if it's white, if you tint it white, it means you haven't changed the color at all. But if you set this last value, the A, the alpha, the transparency, you can affect the transparency of the sprite or the sprite image and so on. So by setting it to 0, that basically makes it invisible, right? It makes it fully transparent. So my fade-in routine here, the goal is to start off at totally transparent. So it comes in here, it says, okay, totally transparent. And then I have a for loop, which will run slowly or quickly or whatever, incrementing the alpha value over the course of a second, right? So each time this loop iterates here, it calls yield return new wait for seconds 0.02. So a 50th of a second. And it's going to run through there until it hits 1. Right? So the last time in, it's going to give me that last 50th of a second I need. Is it precisely 1 second? Well, I think it should basically work out to that. And the last thing it does, just to make sure, is it sets the color to fully opaque and set the tint all the way back to 1 again, right? And this is what we see if we go to the ship controller, or the ship's sprite renderer. You'll see up here the color. Right, here's our color here. It uses 8-bit color, but you can think of it as this, right? So this is varying from 0 all the way to 1. To turn off the collider, Dylan's asking, not sure if this has been, I will talk about turning off the colliders, or how I'm doing my collisions, or how I'm disabling weapons and stuff during the fade in a moment. We're going to look actually at the other one. So that's the fade, right? So the cool thing about doing it this way versus doing it in, say, a animation, is normally we have to set up an animator, then we have the animation controller, and we have the state machine, and so on. I've effectively created this little animation just as a little class, and I can drag and drop this on anything, right? Yeah, you guys are getting ahead of me. So here, so say any of these coin sprites, for example, we're going to go zoom out to the main camera, come over here, and I'm going to select this coin over here, right? That coin. And I'm going to grab my generic fade. I'll do it over here. I'd say add component and look for generic fade. And now that coin, the moment the scene starts, will fade in, right? Didn't have to set up an animator, didn't have to do whatever. So real simple animation. Now, all right, as Dylan and Brandon are talking over there, let's take a look at the more elaborate coroutine that takes care of the player's ship. A lot more is going on in that coroutine. So that's in the ship controller. So every time the ship controller, or the ship, I should say, every time the player ship collides with something, it will start that coroutine, start this coroutine that's right down here. Now, the way that I effectively disable the colliders is I say, well, all right, this is a little bit of a hack. You can do this. I could have had a specific flag, which would be more efficient than doing a get component every time. But I check. I say, okay, let's look at the color of the sprite. And we say, well, if the color is white, that means it's fully opaque. So that means, okay, you're allowed to collide with it, right? I was using this analogy in my head saying, okay, if the ship is solid, right, meaning this color is white, then I should be allowed to destroy it. So it's going to have special states even to say, okay, if it's green, if it's whatever, different things can potentially happen, but you wouldn't be allowed to collide with it unless it's in its normal, solid, opaque state, right? So it might still bounce around or might have some different things on it in that case. But you could also then determine, you could just say, okay, I want to enable or disable certain components. And I do that in a few lines here. So one of the first things it does, and I guess this could even go in the coroutine as well. No, this one I didn't. Well, I guess I could factor that in a little bit. All right, so here's where I'm invoking the coroutine. I say start coroutine, and I have my coroutine called fade in. Now you can pass coroutines parameters, right? They're just like any other function. So this looks an awful lot like I am, calling this fade in and passing it to start coroutine. That's sort of, looks that way, but this is invoking the coroutine, giving it a parameter. And here's my actual coroutine. So the first thing the coroutine does, it says, okay, turn off any weapons, right? It disables our use weapon, right? The component that our ship uses to actually be able to fire weapons, right? You'll notice there is no weapon firing allowed in here, right? Update here is only about movement, right? There's no firing of weapons. Instead, we have another component called use weapon. So we just go ahead and we disable the use weapon while we're fading in. We've been hit, the game is over, whatever situation we're in, we're not allowed to use the weapons. We disable that. So we could also disable the colliders there if we wanted to, right? So now you'll notice I just said collider 2D. I didn't say box collider 2D. I didn't say circle collider 2D. I didn't say, what other collider 2Ds do I have? Box collider, capsule collider, circle collider, composite collider, edge collider. Didn't say any of those. And you'll notice over here, I don't have anything called a collider 2D. So anyone want to tell me what's going on? What's that an example of? Inheritance. Exactly. Right? The cool thing is I can just say, all right, let's refer to the base class for all of my other colliders. Right? So if I were to have this function, I want to use it for any number of different objects, I wouldn't care what type of collider it even had, as long as it had a collider 2D. Right? I could even go one step further and check for the existence of a collider 2D first. But in this case, I know there's a collider 2D, so we're okay. Now, I'm going to also, at some point later on, chances are, down here, let's turn it back on when we're ready. All right. So that's a good thing to do. Yeah. So now we've disabled our colliders. We also set the color to clear. So obviously, the moment I call this, I can no longer have this happen either, right? So if, basically, I don't need that anymore. We've just disabled that from happening because we've disabled the collider. All right. I don't attempt fade too much, but we'll try that. So I set the color to clear. I disable the collider. I disable the weapon usage. So even if the user tries to click, nothing will fire. And then I wait for the number of seconds I'm passed in. I'm going to wait for 2 seconds just to say, all right, time to let that defeat settle in. The fact that we just exploded. Give us the 2 seconds. Like, oh my gosh, drama. And then I have to make some decisions. I say, okay, if I've got remaining lives, I basically want to fade back in again. I've got a little bit of logic here to say, all right, well, I'm going to do a little bit, I'm going to be a little bit fancy. Now, one of the things, I do have my life counters that I disable that are on the canvas, but I also have a little bit of fanciness to have it rotate the colors, to tint the color as it's fading in. So as I'm watching, if I see that I fade in and it's green, that means I'm on my last life. If I fade in and it's red, that means I'm on my second last life. Fading in on blue, that means third, and so on, right? I thought that was kind of a cool added feature. So this is the fancier, I take my temporary color up here, which has an alpha of 0, and I add this other color, which is the one that adds in our alpha value. But similarly, it looks, a lot like our normal fade in. And then when it gets all the way through the fade in, it goes ahead, sets our sprite renderer, tint, and everything back to solid. It'll turn our weapon system back on, and it'll turn our collider back on. Right? If I didn't have enough lives left, if I had no lives and I collided, it would say, instead, I would enable, and I don't know why I had that one there. I forget what that was for, and I asked myself that in the class earlier. And then I do fade in. I just do the fade in with red here until I get to a solid red color for my text. So if the game is ended, I fade up, and then I hold here. I say, all right, 5 seconds must pass with the game over text on the screen. So then after that 5 seconds, I restart the game. And I do that in a brute force way. I haven't done everything I need to here. I haven't reset the time, or I haven't reset the spawn. It's just whatever happened to be there. I haven't reset the score still happens to be there. I know I have to change that, but it does, help for testing purposes to just say, okay, restart the number of lives, or set up the number of lives, reset the counters on the screen, take the text off the screen, and put me at the center, and go ahead. And I start this coroutine again so that it will fade me back in, right? Because I always fade in at the beginning of one of my lives. So I like this approach because, again, I remember that I think the first time I did this asteroids game, it was similar to how we did the player in the tree in the apple picker. And there was always a player object that was sort of just the invisible object that moved around. And then I would put the sprite or the actual player controller thing on that and delete it if it got destroyed. So there's actually, you could destroy the player and you'd have to reconstitute it whenever you wanted to spawn a new life and all that. But this one, I like, just saying, okay, there's always the player on the screen, and we just have to manage, is it visible or not? Is there a certain number of lives left? And it's, a little bit leaner, different approach to it. Okay. So that's my fancy coroutines for coming back in the game. Now let's go ahead. Let's see if that worked. I'm going to go ahead and get rid of this color checker here. Right. So the moment I get in there, I disable that, and then I only re-enable it if I have a life left. Right. I wonder if that's going to have unintended consequences. I'm always worried about unintended consequences. Let's see. So here I am. Notice it faded in on blue. All right. And there we are. Oops. That wasn't great. Where are we? Oh. I know why this is not exactly ideal. The one cool thing I like about not disabling the colliders is that as I come up, as I'm spawning, the cool thing is if I leave the colliders on, but I don't die as a result of hitting the colliders, is that enemies will bounce off, right? They may even explode. I may score some points. Maybe that's, cheating a bit. But the nice thing about them bouncing off is that I won't accidentally spawn on top of them, right? Or if I do spawn on top of them, they'll get pushed away immediately because the colliders actually exist. So physics will help out there. So in this game, this version of the game, it's a little bit more brutal because it potentially will allow me to spawn, to come back while something else is in the same spot as I am. And that's a little bit scary. Let's get a weapon here. All right. Way more effective when you have the Ultra Blast weapon here. Oh, well. Any other questions on coroutines, I guess? Now we're getting to sort of a little bit more finesse sort of things. I can talk about this weapon system if we like. All right, I'll pause for a moment. Any questions on coroutines? No? Everybody's just, 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 no? We get a cool echo there. 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 Did anyone else hear that echo? Did anyone else hear that echo? Did anyone else hear that echo? Is it still there now? 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 1, 2, 3. 1, 2, 3. Still echoing? 1, 2, 3. Still echoing? 1, 2, 3. Wow, what caused that? Wow, what caused that? How about now? Is that better? Ah, that's interesting. Some reason it was like feeding back through OBS all of a sudden. That was weird. Did I hit a button? Weird. Okay, so we're good on coroutines then. Do you want to hear about the weapon system? We're ahead of time here. We have we have 15 minutes. So I'll open it to the floor. Who wants to hear about what? If there's interest, I'll talk about the weapon system and inheritance. I'm kind of excited about the way this weapon system works. So want to hear about the weapon system? Is that a yes? A thumbs up from anyway? What do you think, Charles? Is that a thumbs up? All right, we got 15 minutes. Let's make it worth it. All right, so this is the my cool weapon system that I decided to come up. Okay, so by default we have our simple pea shooter, and the scary thing is, well, the enemy is pretty scary nowadays, and you'll notice the enemy actually also picks up weapons, and I had to write virtually no code for the enemy to do that. The only thing I had to let the enemy know how to do was how to fire the weapon. And it was relatively simple. I just said, okay, enemy, you will randomly fire this weapon roughly every 2 seconds. So that's all the enemy needed to do, to know how to do in order to take advantage of the weapon. There was no code change to actually even in the enemy's behavior. Instead, it was just like a bit of another, there's a series of scripts that I use to make this happen. And we'll go over here. So this is extensive use of inheritance, a little bit of add components, and a little bit of magic in between things. So to look at it, the first thing we need to do is say, all right, well, we're going to have a base weapon, right? Let's talk about a base weapon. And even the base weapon now is slightly more complicated than it needs to be. And this was to accommodate using it even in the Flappy Bird game. So yes, the Flappy Bird over in the other game, and even the our hero of the forest, Fred, could use this weapon now, which is frightening, right? Because normally this weapon, you'll say, okay, just fire the weapon, right? Fire the weapon, and it will fire in whatever direction you are facing, right? It'll use your transform position and your transform rotation to determine what direction to fire in. And that works fine in the game that we have right now, where we are, where we have a direction to fire in. But in something like the Flappy Bird or the hero in the Adventures of Fred, there's no direction other than whatever. So we need to give have another way of telling what direction to have. So I overloaded the fire function. One case is just, okay, fire based on your current position and your current rotation. The other one say, okay, fire, but give a position and a direction, right? So the bullet, whatever bullet is, you will start at this position and you will fire in that direction, right? So we have two versions of fire. We have basically done a little bit of polymorphism here. And in the end, there's like the hidden version of the fire function, which, uses quaternions and a little bit of rotation to kind of really do what it's doing. But like I said, in one case, it just does, passes that function, the position and rotation. The other one, it does a little calculation to figure out, okay, based on this direction vector, turn that into a rotation for me, right? So here's a good tip. If you're looking for use this, steal this code, right? If you want to rotate, if you want to do a quick change from the up vector, you can use vector 2, get a signed angle, pass that into the z value of your quaternion Euler function, and that'll give you the rotation as a quaternion, right? So the other cool thing this will do is I say, if I pass in direction that is a direction right, it will do the difference, right? So you can have it do different things. All right. So that's the basic piece of this function. It really is just about, and it has a default, if it starts, it will load this bullet so it knows what to fire, right? But that's all it does. You notice it doesn't actually fire it. So the question becomes, okay, now we have a weapon that could be fired, but who's going to fire the weapon? And we have this thing called use weapon. And use weapon is just another class that all it knows how to do is to say, okay, during update, check to see is the mouse button pressed. If the mouse button is pressed, see if you have a weapon. And if you have a weapon, go ahead and shoot it, right? It doesn't know what kind of weapon it is. It just knows that it's a weapon. And a base weapon, I know how to shoot a base weapon, right? I just call fire, and maybe I give it my position and my direction to shoot in, right? So that's the basic how to use a weapon. So I can put use weapon on anything that knows how to do input, get button, mouse, or anything I want to have capable. So this is the player's version of using a weapon. There's another version of use weapon, basically, called auto weapon, which will fire according to an invoke. So we're just going to keep firing every 3 seconds. Otherwise, it looks an awful lot like our other function there, right? If we looked at, let's see, put use weapon there, right? They look very similar, except one of them has this mouse down. The other one is just invoked, and it just fires every 3 seconds. All right. So the auto weapon is the one I'm going to wind up using if there's something that I want to have capable of using weapons. Let's see, there. Something capable of using weapons that doesn't have a fire button. So any kind of AI that I want to have just randomly do something, I would have to use the auto weapon. So something has to have either a use weapon or an auto weapon on it in order to know how to use a weapon. So that's the only bit that the player really has to begin with, right? So if we look at our player, the player does have a use weapon. And by default, I'll give it the base weapon. So I'll put the base weapon on there, the use weapon. So now if I press the button, it will use whatever weapon it has already on it. Okay. Now, it used to be that the tricky part was, how do I give the player a new weapon? Do I have to have the player know about the weapons? Do I have to have the player choose between, depending on what it collided with and all that kind of stuff? And you'll notice in neither of these or the player's normal code anymore, there's no colliding with power-ups, right? I think the only thing that might happen as a result of colliding with a power-up is it deletes it, just gets it off the screen. It doesn't actually do anything. It doesn't change anything. Instead, there's this, what I think is a fun little class called the give weapon. And if you put a give weapon on something, it means, okay, if anyone collides with me, I will try to give them the weapon that I have on me, or I will at least try to clone the weapon that I have and give them a copy of it, which is why our enemy now can fly around the screen and accidentally bump into things and pick up weapons, which makes the enemy scary. So what happens here is that it just has a single method for on trigger enter. So if somebody collides with me, right? If somebody collides with me, I check and see, okay, do they have a weapon? If they do have a weapon, get rid of that weapon and see what my weapon is. If I have a weapon, add that weapon to them. Now, the weird thing is, if the asteroids had a auto weapon, they would also be, I hadn't even noticed that. That's a weird thing. Let's look at this. Asteroids are colliding with these coins at some point. All right, I'm going to do this without maximize on play. Unintended consequences. I'm sure these asteroids are being given weapons. We're handing out weapons like nobody's business. It's terrible, like totally indiscreet arms dealers here. All right, that asteroid there just crossed over that weapon. And you'll notice now this asteroid has picked up the Death Spiral's weapon. Totally terrifying, right? So anyone who bumps into these things will pick them up. I've made it so that they don't get destroyed. They only go away when the player picks it up. But everybody else can pick up these weapons. Terrifying. So I've got to try this. I'm going to put the auto weapon now on the asteroid sprite. Right? Here's our asteroid sprite. All it needs to know is, yeah, this is going to be crazy. I'm going to say auto weapon on our asteroid. All right, it's on the prefab now. Oh boy. Now, let's see. All right, that asteroid should theoretically have the auto weapon now. And, oh, it doesn't have bullets. I guess that's the one thing I didn't tell it what what to actually shoot. So maybe that's the missing piece for it. But this is the idea. I guess we've run out of time. So the idea is mostly to sort of inspire to say, okay, how could we use inheritance to make very, very flexible system that potentially, if I wanted to add a new weapon type, I would really just need to define what happens when it's fired. And then all of the logic is actually spread to say, okay, who's allowed to pick it up? Yeah, the asteroids with guns blazing. I think let's look at, what did I have to do for this? Yeah, I needed to create an enemy bullet. All right. I'll go ahead and I'll give the asteroids the enemy bullet. And yeah. Because there's the silly weapon. I'll have to show you the silly weapon. Now the asteroids are really going to be terrifying. Especially if I put a bunch of them out there. Got to go away. Come on, asteroids. Pick up a weapon. I dare you. Oh. Oh, nobody. They're all skating clear of it. Oh, so close. I'm going to have to pick up one of the crazy weapons. All right. There I go. Here's a weird weapon. This is the mole weapon. And it allows me to place moles because that's useful. And the cool thing about moles is they look like kind of dirt. And they kind of get things to stick that they can't get past. So I'll do this. I'm going to try to get rid of these guys. Got to get rid of all these asteroids so that some new asteroids will come around. Oh. Or is there an asteroid? There it is. Stuck in there. All right, asteroids. Did the asteroid pick up any weapons? I thought it did. Well, that enemy's got weapons. Seconds. I guess I maybe didn't think it all the way through. I'll have to fix that. But in theory, the asteroids should be able to pick up weapons and fire bullets. I don't know why. What's probably, I know what's happening. The asteroids aren't tagged as enemies, so they're destroying their own bullets as quickly as they make them. That's the problem. There's a collision issue, right? Whose bullets are allowed to hit what? So the last piece of the puzzle. So you're going to hang around here. We're going to end our Friday on a good note here. We have to go in here. We have to tell the asteroid sprite what layer it's on. So by default, it is on the default layer. It needs to be on the enemy layer. And now, all right, now we're in trouble. All right, now the asteroids are shooting. And so, oh boy. So this asteroid's about to pick up. Yep, it just picked up the mole weapon. Let's see if it starts leaving moles behind. Oh, no, moles can't. Moles will be destroyed when they collide with someone that they're not part of. So this asteroid is really badass now. All right, so this is kind of emergent behavior, right? Without going in and saying, okay, let me change the asteroid behavior. All I have to do is say, okay, it can fire a weapon now. It's picking them up. I might as well let them shoot them. It's kind of weird, right? Imagine you had robots running around and be like, okay, what can I do? It's like, oh, they'd be handed a weapon and carry around that weapon. And the other weird thing is you could do things like, well, okay, if that weapon was carried, then it could decide, okay, now I'll bump into things and I'll give people that weapon, right? So Yeah, by using inheritance and using add components, you can get really clever and carried away. The basic use of inheritance doesn't have to be nearly as bonkers as this one is, but it's potentially fun. Right, that's the purpose of this class, to show you that programming can be fun. All right, it's definitely 4:22, which brings us beyond. I thank you for your patience and your, especially with the computer crashing right smack in the middle of things. But hopefully this inspires you. We got some time before the project is due, so definitely you should be working out now what assets. I don't want to see everybody using the same asteroids as I'm using the same, but you use some time to figure out where you want to go with it. Come up with some potentially maybe some clever things, whether they're guns or behaviors or whatever. And then so spend the weekend sort of designing, at least, if not experimenting with some of these techniques. And then by next week, you should be like, okay, now let's focus and get the game built, right? Maybe save some of these ideas for the final project. All right, have a great weekend. And happy, it's not spring yet, is it? No, next week? Is it spring next week? It's getting close. Holy cow. Terrifying, not terrifying, wonderful. All right. Have a great weekend. Have an extra great weekend then. The last weekend before spring. Aloha.